Hi, welcome to Raaonline. I am Dr. Alice, Associate Professor in the Department of Microbiology. In today's lecture, we'll be seeing about anthrax. So now, anthrax is caused by Bacillus anthracis. Can you see this picture? What does it symbolize? It is a bioweapon or a biohazard symbol. And Bacillus anthracis can be used as a bioweapon. Let's check this case. Here is a 46-year-old man who is an abattoir worker, that is, who works in a slaughterhouse, and he attended the OPD with complaints of raised, painless lesion over the right forearm for a duration of 1 week. He gave a 3-day history of fever with chills and rigor, and the skin lesion started to discharge pus, and it became hardened and it turned black. And on examination, a scar was noticed on the dorsal surface of the hand, and the exudates of the skin lesions were sent to the laboratory, and the gram stain revealed the presence of gram-positive rectangular bacilli with non-bulging spores. So these are the clue that we get that it could be anthrax caused by Bacillus anthracis, the black scar and gram-positive rectangular bacilli with bulging spores, and it is an occupational disease. A person works in a slaughterhouse who comes frequently in contact with animals. So to introduce this bacteria, Bacillus anthracis, it's a spore-forming bacteria, and the Gram's reaction is it's a gram-positive organism and it is a bacilli. And this bacteria, when you do a gram stain, it tends to decolorize easily, and usually it appears gram variable in gram stain. And most of the species of the genera Bacillus, they are motile with a peritrichous flagella, except Bacillus anthracis, which is non-motile. And you have two important pathogenic bacteria under the genera Bacillus. One is Bacillus anthracis, which causes anthrax. The other one is Bacillus cereus, which causes food poisoning. So this bacteria, Bacillus anthracis, has got some historical importance. This was the first pathogenic bacterium that was observed under the microscope by Polander, and this was the first bacteria that was isolated in pure culture by Robert Koch, and Koch's postulates were postulated based on this particular bacteria. And this was the first bacteria found to transmit communicable disease, and this was the first bacteria from which a live attenuated vaccine was prepared by Louis Pasteur. Coming to the morphology of this bacteria, it's the largest pathogenic bacterium, and usually it will be arranged in single pairs or in chains. And from cultures, when you do a gram stain, you see the bacteria arranged end to end in long chains. That gives you a typical bamboo stick appearance, and the ends of the bacteria will be truncated or concave in nature. And this is a capsulated bacteria, and the capsule is made up of polypeptide or glutamic acid, and the capsule can be enhanced in the presence of carbon dioxide or bicarbonate. So this is how you appreciate in a gram stain when you do it from a direct culture. Long chains of bacilli attached end to end, and they have truncated ends, giving the bamboo stick appearance. And is a spore-forming bacteria, and the spores are formed only in culture or in soil. It is not formed in animal body or in human body. And sporulation happens when there is unfavorable condition exist, and they require oxygen, and it is encouraged with distilled water and 2% sodium chloride, and it gets inhibited in the presence of calcium chloride, and this bacteria produces non-bulging spores. The size of the spore will be same as that of the vegetative cell, so it gets accommodated inside the vegetative cell and it does not bulge outside. And the placement of the spore, it can be centrally placed or it can be subterminally placed, and the shape of the spore will be elliptical or oval in shape, and hence they get accommodated inside the vegetative cell. So this is how it gets accommodated inside the cell without any bulging. And fat globules can be stained by Sudan black, and there is one important reaction which helps you in the presumptive diagnosis of anthrax. So here the reaction is called McFadyen reaction. Say the blood films containing the anthrax bacilli can be stained with polychrome methylene blue, and when you look under the microscope, you'll be able to appreciate some amorphous purplish material around the bacteria, and this is nothing but the capsule. So this helps in the presumptive diagnosis of anthrax. Cultural characteristics of this bacteria: it's an aerobe or facultative anaerobe. Optimum temperature is 37, that is our body temperature, and the optimum temperature for sporulation is the room temperature, that is 25 to 30 degrees Celsius, and it is usually formed in unfavorable condition in the soil. And this is a non-fastidious bacteria. It can grow in ordinary medium like nutrient agar. So in nutrient agar, it produces round, dull, opaque colonies, and that gives you a typical frosted glass appearance or ground glass appearance. And under low power microscope, when you see the edge of the colony, you'll be able to appreciate large chains of bacilli that are entangled with each other, giving you this locks of matted hair or medusa head appearance. So this is how it appears when you see under the low power microscope. This is a direct colony appearance. So you know how the medusa head will appear. It has tentacles all over the head. So that's how the colony will appear when you see under a low power microscope. And other cultural characteristics: it is non-hemolytic on blood agar, and in gelatin stab, it liquefies gelatin, and the liquefaction will proceed from the top to bottom, and this gives you an inverted fir tree appearance.